Tachometer. Tachometer are speed transducers used with feedback elements in control system applications. So there are two types of tachometers. One is called DC tachometer. Uh, in DC tachometer, the small DC generator is used whose input is mechanical speed and output is electrical voltage proportional to speed. And there is also a AC tachometer. So in AC tachometer, the circuit diagram is like that. We draw here. There is two windings which are perpendicular to each other. One winding is called as a reference winding, and this will be the winding, the E0 supply voltage, and that is the ER reference winding, and in between the rotor is connected to the load. So load having inertia and speed will be theta or omega radian per second. So this is the rotor. So with these two windings are always connected in parallel, connected in perpendicular, and one of the winding is excited by the constant voltage, and that voltage is constant. That's known as a reference winding. When the rotor is stationary, the peripheral flux links the reference winding, and as the rotor rotates, the rate of change of flux induced an EMF which is directly proportional to the speed of rotor. The AC tachometer is also known as the drag cup generator because the rotor shape is a drag cup. So here we can see DC tachometer, we are using a small DC generator, and AC tachometer, this AC motor is used here, AC generator is used here. So now we will see the transfer function of the tachometer. Transfer function we can find out. We know that output voltage is proportional to the speed. So there is two type of speed. In one case we can say in theta, and another speed we can take as a omega. So in first case we can take as a input is theta and output is E0. Similarly in second case we can take as a input is omega and output is we can take as a E0. So from that expression we can find out E0 is proportional to d theta by dt, and we can also write as E0 is equal to k t d theta by dt. Similarly here we can write as a E0 is proportional to omega, or E0s we can write as a kt omega s in Laplace form. So this also Laplace form we can write as a E0 s is equal to kt into s theta s. The Laplace of d theta by dt we can write as E0 s is equal to kt s theta s. So these are the two functions we can find out, and based upon we can make a transfer function. In this case we can find out. So in this case we can find out theta s is kts and E0 theta s, and in this case we can find out the omega s input, kt will be the gain and E0 will be the output. So these are the two transfer functions equations we can find out. First equation is like this and another is like this. So transfer function of tachometer E0 by theta s we can write as kt into s. So this is all about the tachometer. Thank you very much.